Hello, we're on activity 3. We completed activity 1 and 2 yesterday. We are on pages 39, 40, and 41. We're going to complete this, and then later on in the class, you're going to be working on the assignment associated with this lesson. But we'll talk about that later. All right, so activity 3 is verifying congruence using translation. So we know that two figures are the same shape and same size. But from there, how can we prove that using translation or sliding from one figure to the other? For number 1, determine the translation from each vertex. A vertex is just a point on a figure. So we have 4 points here. Point C, D, E, F. This is a 4-sided figure called a quadrilateral. For the most part, we're probably going to abbreviate as just quad. Anyways, so going from quadrilateral C, D, E, F to quadrilateral C prime, D prime, E prime, F prime. We already have the points listed here, and we can use those points, but I'm going to express it mainly just from the graph for this example. All right. Now what I'd like for you to do, starting out, we'll go in alphabetical order. Let's connect corresponding vertices. So what I mean by this, C to C prime. So this is something that definitely connects here. Now, typically when I draw a line, I'm going to draw an arrowhead because you start with your pre-image, you translate it, and then you get to your image. In this case, the arrowhead's going to go this way. All right, so we're starting with C and then ending with C prime. Okay, so we're going to do this for all the other vertices as well. But first, working with C to C prime, you're just trying to figure out what is the path from here to get to the arrowhead of this arrow. It doesn't matter which way we go, whether we start counting up or left, but those are pretty much the two directions I need to go to get to C prime. I'm going to start up just because it's kind of, there's more space up here. So this is 1, 2 up to get to the same height. And then moving left, 1, 2, 3, 4, 5. So 2 up and then left 5. Okay. Let's go and write that in. We'll say, I'll just put left 5, comma, up 2. All right, now moving on to D. So now let's connect those 2 points. All right, now that's very close to the line that we have for C to C prime, so just be careful here. Let's see if it's the same. Oh, sorry, let's go ahead and put our arrowhead like that. All right, I'm gonna go up 1. Looks like I'm still going up 2. And then going to the left, 1, 2, 3, 4, 5 to get to that arrowhead. So same exact thing. So we're 2 for 2 here. You know what? Instead of writing out the words, I'll just put left 5, up 2. All right, now let's move to E, the next one. All right. I'll switch my directions. I'll go left for this one. 1, 2, 3, 4, 5 to get to the same right amount to the left, and then 1, 2. So same exact thing there. Left 5, 2 up. And the last one, if this one works out, it means that they are congruent. Right? It's not always a given that they will be, but this one, it's going to be, because we're going to go 1, 2, 3, 4, 5 left, 1, 2 up. Same exact thing there. All right, great. So this, nothing too simple. Like the only math that's really involved is counting. maybe directions as well, but not too much there. So from this also, just kind of want to point out though, that we have these lines here. Something that we should note for a translation is that these lines, or these arrows, or they're called arrays. I'm going to put an arrow head through them. In geometry, this means that those lines are parallel. Like if you see this, these lines will never intersect each other. Even these two at the top, those are very close, but they will never intersect. And then secondary, the thing that we had noticed earlier is that these are all the same exact size and direction. So that's something that's cool to notice here. So that's a property that we have for translations. All right, anyways, so number 2. Is quadrilateral CDEF congruent to quadrilateral C prime D prime E prime F prime? It is yes. Yes, they are congruent. But it does say explain your answer. Is because we have the same translation. I'll abbreviate translation like that for each point. Or we called it vertex here. I'll put /vertex. Okay. All right, good work there. Moving on to the next page. All right. And if I'm going a little bit too fast, maybe just pause it. Make sure you get what you need to get, and then we can move on. All right, and number 3, describe a sequence of translations to show that figure A and A prime are congruent. Same thing for B and B prime, they're congruent as well. So it's already telling us that the figures that we have here that we translate, those are all going to be congruent. Now, we're not going to do all 4, which is 2 for A, 2 for B. Let's just kind of narrow our options down. Let's cross off. Let's cross off B here. No, we'll do A's. We'll cross off the B's. Okay. Now, with this same exact thing, I'm going to pick a corresponding part here. In this little, I don't know what to describe this, like little castle thing. Maybe the White House or something. We're finding the bottom right corner or vertex. We're just connecting those. Now, maybe just think to yourself, which one do you think the arrowhead belongs? Does it belong this way? Like if it belongs that way, I want you to like touch your left ear. Okay. Now if you think it goes this way, I want you to like stroke your chin. Okay. Now those that touch their left ear, that they are correct. Okay. Or we have it connecting from A to A prime. Right, it's got to connect to the image. Right, that little tally mark tells me some type of transformation has happened, and that is a translation. Okay. Now, we don't have to do this for all the other points. We're already saying that A to A prime are congruent. We're just saying what is the translation here. So we're going to start from this endpoint and then get to that arrowhead. Now, we said earlier, it doesn't really matter. I could start going up, or I could start going right. Or we'll still get this to the same location in the end. You really can't go left though, and you can't go down. So those, not good. Okay, but which way are we gonna go? Really doesn't matter. I'll go to the right. So 1, 2, 3, 4 to the right, and then 1, 2, 3, 4, 5, 6. 6 up. Okay, so for this, we're going to say that A, or I should really say figure A. So figure A is congruent to figure B. I'll put figure A prime. And it's because a translation of 4 right and 6 up. All right. So like this is, we're just starting off very basic in transformations. Translations is usually the easiest transformation. But I think even from there, right, we can clearly see, right, we're just counting, just figure out directions there. But let's go and get to the next one for a little bit of practice. on part B, still working with the A figures, A to A prime. All right. Okay, we're gonna go with this one right here. All right, which one do you think the arrowhead belongs? If you think it belongs over here, I want you to touch your right shoulder. Okay. And then if you think it belongs over here, I want you to blink twice. I'm very curious if anyone is actually doing this. Anyways, for those students that are blinking twice, you are correct. Great job. Okay, but let's go and count. So we're going to start with, let's go, I don't know, let's go down. We'll go down 1, 2, 3, 4, 5, 6. So I'm at the same height now, so 6 down. Now I'm moving to the right. 1, 2, 3, 4, 5. To the right. Okay, so these two things, we know that they're congruent. The problem said it was, but let's go and write it in. So this is, we're just going to say that all points are shifted six down and 5 right. Wow. I don't know what that is. That's supposed to be a D. All right, anyways. Good. Okay, and let's go on to our last page here. That is page 41. Okay. So this slightly different, but really not all that different. Number 4. For each example, decide whether the figures given are congruent or not congruent using translations. So are they not? Are they or not? And then show your work and explain your reasoning. All right, so same exact thing here. You would go through really like all the same points and figure out what is that translation. I'm gonna go through the bottom left here, and then we'll try to see if there's any others that either reaffirm that translation or provide a counterexample there. Okay. So this is, I'm gonna go, it doesn't tell us what is the preimage and the image. That's not super important. We're just seeing, are they the same shape and same size? So we're gonna go down 1, 2, 3, 4, 5, 6, 7, 8. So 8 down. And then 1, 2, 3, 4, 5, 6. Did I count that right? 1, 2, 3, 4, 5, 6. 6 right. Okay. I'm gonna erase the past here, but I'll keep the numbers there. Let's use another point here. I'm gonna pick the top apex of this right triangle. Okay. We're gonna do the same exact thing. I'm gonna count going right though. 1, 2, 3, 4, 5, 6. All right, so far so good. That's the same thing going on over here. Now let's count down. 1, 2, 3, 4, 5, 6. We got a 7 down. That does not match with going 8 down. Okay, so this, we're just gonna say they are not congruent. So congruent means same shape and same size. They may seem like the same shape, and I mean, like, yeah, sure, they are right triangles here, but same shape would be right with the same dimensions. Same size would be that they're right, same side length for all 3 sides of this right triangle. It would be similar if they had like some type of same type of proportion though. Like I'll give you an example here. If I trace this purple thing, purple triangle, is congruent to this blue thing right here. Okay, the one that I just traced it on. If I take this, actually I don't know if I can make that bigger. Oh, I can. So that is something that's similar to this. It's the same shape, but it's definitely a different size, right? It is way too big. It's like we talked about, like Ant-Man. All right, I'm gonna try to get this. Ooh, I have messed it up. Yeah, close enough. Now, if I kind of superimpose this on here, yeah, no. This is same width, but it does not have the same height. This is actually a stretch. I've stretched this vertically. So this is why it's not congruent, right? It's not even the same shape, not even the same size. This, not congruent. Okay. All right. B. Let's go and pick a couple of points like we did for the last one real quickly. Just kind of further reinforce this. Okay. So this is, we're going to go down 1, 2, 3. So 3 down. And then 1, 2, 3, 4, 5. Right? Okay. And then now let's do, we'll pick one more point. I'll pick the like knuckle of this thing. Okay, let's start going to the right. 1, 2, 3, 4, 5. Right. Now let's go down. 1, 2, 3 down. Yep. 5 rights, 3 down. This is congruent. I mean, you could try the other ones actually. I should probably try that, but the thing is, for the sake of time, I'll just tell you that these are congruent. And the reason is because they are all moved. We'll just put this in shorthand. 5 right, 3 down. All right, great, almost done. Let's get to that next one. Do these two things look like I just took one, dragged it to get to the other one? Okay, so they might look like the same shape, they might look like the same size. Sometimes it's hard to verify, but let's pick a couple of things here. Let's pick this one, and I'll pick the top right. Okay, does this line look like this line? That I don't think so. Okay, but you don't really have the option to maybe take a line and just drag it. So let's prove it. Okay, this is going down 1, 2, 3, 4, 5, 6. So 6 down. 1, 2, 3. So 6 down, 3 right. Is this the same thing? 1, 2, 3, 4, 5, 6. Okay, that's good. But this, we're going 2 to the right instead of 3 to the right. So this, a little bit scandalous, right? This is not congruent, just like that first one that we had. So unfortunately, we're going to put not congruent. They might look like it, and it might be kind of an optical illusion for some students, right? These might look like the same thing, but they are not. So, I mean, if I trace this, we'll see. Yeah, no, not the same thing. Okay, and now moving on to our last one here. D. Can you verify that these two figures are congruent using only translations? So if I go to triangle ABC, can I slide it, translate it to get to triangle A prime, B prime, C prime? I think we can kind of tell from it, but you know, sometimes it doesn't hurt to just maybe draw it in, think about it. And this is not quite perfect. Right, can I take this triangle and slide it in a way so it can be on this triangle? The answer is no. Okay. So this, it says explain our reasoning though also. So no, there's no way I can do that. But we need to understand though that these two triangles, even though we can't prove it via translation, the first transformation that we're really exploring, these two triangles, so we're going to say triangles are congruent. They are the same shape. They are the same size. But we're just going to say, but cannot use translations. There's some other transformations. Maybe think to yourself what that transformation could be. We'll explore this transformation actually pretty soon. But yeah, that's pretty much it. So make sure you have everything. When I get back to class, I'll be making sure that we have all notes written down, everything in our book written down as well, and that we have completed our assignments. So you're going to move on to the next assignment, which is at the end of this lesson. But yeah, thank you for your participation and concentration. Appreciate it.